Assalamualaikum and hi everyone. Today our group going to present Stirling cycle closed regenerative heat engine. Let's go. This is our group members. So first is Muhammad Adam, Faris Razik, Muhammad Mirza Shah, Munirah Najihah, and Nur Amirah Aiba. So our content for this presentation is introduction, historical background, four phase of Stirling cycle, basic component of Stirling engines, type of Stirling engines, advantage and disadvantage, application, recent development, conclusion, and reference.
So, what is a Stirling cycle? Stirling cycle is a type of closed-cycle regenerative heat engines that operate using heat source. It involves four main processes. First, constant volume heating, isothermal expansion, constant volume cooling, and isothermal compression. So, I want to share a little bit about historical background of the Stirling cycle. The Stirling cycle was developed by Robert Stirling in 1816 as a safer alternative to steam engines. Its design introduced the regenerator, improving efficiency by recycling heat. Initially used in small-scale applications like pumps, the engine was later overshadowed by steam and internal combustion engines. Interest revived in 20th century due to its high efficiency, low emission, and ability to run on various heat sources, making it useful in solar power, submarine, and cooling system.
Hi, Assalamualaikum. Today, I will explain about the four phases of the Stirling cycle, which is a type of the heat engine cycle. This cycle is known for being efficient and environmentally friendly. It consists of four key processes, which are the isothermal compression, the constant volume heating, isothermal expansion, and the constant volume cooling. Let's go each phase step by step. The first phase is the isothermal compression. In this phase, the gas inside the cylinder is compressed at a constant temperature because it is in contact with a cooler. As the piston moves in, the gas volume decreases and its pressure increases. The heat is removed from the gas to keep the temperature the same. The system here does negative work, which means the energy is absorbed by the gas. The third phase is the isothermal expansion. The gas expands at a constant temperature because it is in contact with the heater. As the piston moves out, the gas volume increases while the pressure decreases. To keep the temperature constant, heat is added continuously. In this phase, the gas does positive
The
work by
heat
pushing the
source
piston
used
out.
in the Stirling engine is separated from the
And
internal
now,
working of the
the final
engine.
phase
The working
is
fluid
the
have no contact
constant
with the heat
volume
source.
cooling.
This opens
Here,
up the
the gas is
potential for the
cooled
engine to
while its
operate on a
volume
wide range of
remains the same.
materials
The
that
gas
emit
flows
heat.
back through the
Example, biomass waste from
regenerator
landfills,
to the cooler.
solar
Heat
energy,
is removed,
geothermal
causing the
energy, and
temperature and
radioactive
pressure to drop.
sources.
This
And it
completes the
also
cycle
provides
and
alternatives
prepares
away
the
from the
system to start
traditional and
again from the
increasingly
first
harmful
phase.
gasoline with its pollutants and greenhouse gas emissions. This makes the engine environmentally friendly given the right choice of heat source. A flywheel is a device that is often used in the movement of the piston. It is not shown in the slides, but the crankshaft is attached to the piston. The flywheel transmits kinetic energy from the piston to rotational energy of the crankshaft about the rotor. So, in simpler words, as the crankshaft rotates around the rotor, the piston moves up and down according to the position of the crankshaft. This component is more prominent on gamma type engines used as toys of curiosity. The types of engine will be explained later. Regenerators are a very distinctive part of the Stirling engine. Theoretically, with a regenerator, Stirling engine is able to achieve Carnot thermal efficiency. However, real-life applications encounters friction as well as the fact that the temperature and pressure is not equal throughout the working fluid, which complicates the math behind the engine. In beta-type Stirling engines, which was the first design that was patented by Robert Stirling, there is no difference between the roles of the displacer and the regenerator. As the plunger displaces air, it exchanges heat. The plunger was the name for the displacer and regenerator. But the alpha type engine differentiates between a displacer that displaces the air, a working piston that regulates the pressure, and regenerators that are made up of fine wire mesh that absorbs and releases thermal energy.
Hi, I'm gonna explain about types of Stirling engines. So the first one is alpha. There is the diagram here. So alpha contain two separate cylinders, one hot and one cool with a power piston in each. Gas shuttles between the hot and cool cylinders. One piston compress the gas in the cool cylinder, while the other expand in the hot cylinder. Highest potential power output and efficiency due to the separate chambers, ideal for high performance applications but mechanically more complex. So the second one is beta. Beta has a single cylinder with a displacer piston and a power piston in the same bore. The displacer moves the gas between the hot and cold ends of the cylinder. The power piston extracts energy from the pressure change. Moderate efficiency, simpler and more compact than alpha type, often used in educational models and low power application.
Today, we're exploring the
So the last
Stirling
one is
engine,
gamma.
a
So
hidden
gamma is
gem of
similar to
clean
the beta
energy
type, but the
technology,
power piston
whether in the
is
depths
in
of
a separate
space or
cylinder
remote
from the
corners of
displacer
Earth.
piston.
Its
The
unique design
displacer moves
unlocks
gas between hot
efficiency
and cool
where
zone,
other engines
and the
fail.
separate
Let's
power
break
piston
down
respond
why
to
it
pressure
matters.
changes.
So there is
Slightly less
four
efficient than beta
advantages
type,
and
but easier to boot
disadvantages.
and maintain.
Firstly
Frequently
is
used
efficiency.
in
The Stirling
demonstration
engine
and low
promises near
tech
perfect
application.
current efficiency, imaging, squeezing every drop of energy from heat, but reality bites, mechanical losses, and heat leaks drag performance down. Still, its ability to harness small temperature gaps makes it a solar thermal champion. Second, fuel flexibility. Solar, nuclear, even burning coal dung, this engine isn't picky, but beware, inconsistent heat sources need backup like thermal batteries to keep the power steady. Third, environmental impact. Quiet operation, emission free, and perfect for stealth submarines unless helium leaks. Even green tech has trade-offs. Last but not least, maintenance and durability. No valves means less wear, but those high pressure seals? They are finicky and expensive. A classic pay now, save later scenario. So, where does this love-hate relationship shine brightest? Let's look at the real-world uses. There is two applications in Stirling engine. First is space missions and niche energy systems. Space missions have ability to convert heat into electricity efficiently. It also works as power generators, particularly for deep space probes and long duration mission where solar power is unreliable. It also can be used with nuclear reactor or solar energy to power spacecraft, probes, and even lunar or Martian bases. Picture this: a probe orbiting Pluto, too far for solar panels. A Stirling engine paired with a nuclear heat source delivers decades of uninterrupted power, no pit stops required. Second application is niche energy system, where leveraging a Stirling engine is a dish Stirling system. It uses concentrated solar energy to power a Stirling engine, and these systems are particularly well suited for remote areas and offer potential for renewable energy generation, especially when combined with other renewable sources like PV panels. In sun-baked desert, dish Stirling system focus sunlight to outpace solar panels. Off-grid village, they're prime candidates for hybrid Stirling PV setup. The Stirling engine isn't a one-size-fits-all solution. It's a scalpel for energy problems where others wield sledgehammers. Challenges? Absolutely, but when the mission demands reliability over hype, Stirling answers is the call.
Micro CHP, which is also known as micro combined heat and power. A micro CHP is made up of a Stirling engine coupled to a power generator whereby the heat gained from the engine expands the working fluid inside and causes a piston connected to the power generator to create electricity. The micro CHP is often seen as an alternative to a boiler. Stirling engine has all the attractive qualities for household uses, such as the ability to operate quietly as well as having low emissions. However, micro CHP has yet to produce enough electricity to cover the average household's electricity demand, and is yet to overtake CHP in usage. But the future for this device is very promising. Dish Stirling system uses a parabolic dish of mirrors that concentrate sunlight to a central Stirling engine. The dish is on top of a system that tracks the sun's movements and orients itself to reflect the highest percentage of sunlight onto the receiver and then onto the engine. This configuration works so well since Stirling engine is an external combustion engine, and in the engine not one movement is wasted, so it is able to make most of the sunlight power. But it is dependent on the temperature/weather of the day, so the efficiency and power output is not always guaranteed. This technology is currently being used in the United States of America. Air-independent propulsion, aka AIP, is the technology currently used in Sweden's submarine, the Gotlands. The submarine's main focus is stealth. Stirling engine that is silent and vibrations free is essential to the system, and the only variable is the amount of working fluid on board of the submarine. They mostly use liquid oxygen. With this device, the submarine could endure weeks being submerged underwater, and the engine's long service interval makes the Gotlands durable and is estimated to last well beyond 2030. CCHP, Combined Cooling Heat and Power, sometimes called as CHCP, is a process known as tri-regeneration that involves the process of heating, cooling, and power all from a single fuel source. Stirling engine's use in this device is the same as a micro CHP, which is low temperature differential Stirling engine, also known as LTD Stirling engine. There are videos shown on the internet of Stirling engines working with only the body heat from the hand. These machines are often very small and are often the gamma type of the engine. If properly utilized, the prospect of this
In conclusion, the Stirling cycle is an excellent example of efficient and sustainable thermodynamic design. A closed cycle operation, use of external heat sources, and regenerative heat exchange provide excellent efficiency and low environmental effects. Although it was invented more than 2 centuries ago, current technology has revealed its potential for a wide range of applications, including renewable energy systems and innovative cooling technologies. As the globe shifts toward cleaner and more efficient energy sources, the Stirling engine stands out as a timeless innovation with increasing importance. So that's all for me. Thank you.
That's all from us. Thank you. That's all from us. Thank you. That's all from us. Thank you. That's all from us. Thank you. That's all from us. Thank you. That's all from us. Thank you. That's all from us. Thank